What's up guys, JayzTwoCents here, and it's been a hot minute since I've done my how to water cool a computer video. I mean, I think like 2013 was the last time I did it. Although the concepts stay the same, the parts have changed over the years and things have gotten better. So that's why I teamed up with our friends over at Corsair to bring you an updated guide on how to water cool your computer for the beginner. So I think there's this preconceived notion that water cooling is hard. It's really not that difficult. And one of the things that we're gonna show you here is the parts that you absolutely need for the bare minimum of a water loop. We'll talk quickly about how it works so that you understand the concept. And if you understand the concept, then the rest might sort of click. We'll talk about a few different variations on tubing type, pump type combos and whatnot. But then we'll show you guys just really the fundamentals of getting your computer water cooled. So usually at the very bare minimum, people choose to put their CPU on water and then they'll just throw their GPU in there and keep it air cooled. But at the very least, you need a block, whether it be for your GPU or your CPU. So fortunately from Corsair, we've got our XC7 RGB water block that works both Intel and AMD rigs, non-TR4, but AM4 and your standard Intel stuff. But if you want to add your graphics card to the loop like we're going to be adding to our Asus Strix 3090, they do have the XG7 RGB water block specifically for that card. So you can go to their website, check out Corsair's website to see all the different blocks and custom cards configurations that they have water blocks for. So now that you're able to pick up the heat, which is what the water block is doing, it's touching the component you want to cool and it's going to absorb heat. Now you need to get that heat moving through the system, and the way you do that is with a pump. Now we're going to be using the XD5 RGB pump in this case because it is a combo unit. So we have our reservoir on top, which is going to be directly feeding our water pump, which means you don't have to worry about that whole like how high is the block versus the radiator like you deal with AIOs. This is going to handle getting all of the air bled, getting the air trapped in the reservoir, and you can keep topping it off until all the air is out of your system. But the water pump is also included in this, which means you don't have to worry about conjoining them either with tubing or fittings. It keeps things tidy. It comes with its own mounting mechanism that mounts onto radiators and fan slots, keeping it all nice and simple. Now, what do you do with all that heat once you've grabbed it? Well, you need to exchange it. You exchange it with the air. So what you're gonna do is you're gonna install a radiator. Now, what size radiator you need depends on many factors. How many components are you cooling? Are you cooling one graphics card, two, a CPU with two graphics cards, just a CPU or a GPU? And a good rule of thumb is I like to have at least 120 millimeters worth of radiator for every part we're cooling if you're keeping it stock. If you're going to be doing any sort of overclocking, I recommend at least 240 millimeters worth of radiator for every part. So we're going to be running our XR5 360 millimeter radiator times 2 in this system. So we've got 2 of them because our particular 5000D airflow case will allow us to mount more than one. Now I'm going to be going with extra radiator space for multiple reasons. 1, I like to keep the components as cool as possible. 2, I like to fill out the case. It's kind of like if you're going to do a custom loop, you sort of want to go all out and have it be a showpiece at the same time. But you don't have to. You could go with a single rad, 2 rads, 3 rads. You can go with a 120 on the back. You can really scale it to the size that you want. There's really no such thing as too big. There is a such thing as being too small when it comes to radiator size. So that's why I like to stick to at least that 120 per component or 240 per component if you're going to be doing overclocking. Now obviously we're going to be running Corsair fans with these radiators. We're going to be running the QL120 RGB fans. This has LED rings on both sides of the fans. So no more do you have to deal with having the ring on one side, and then if you're pulling air through the front, you can't really see the RGB on the back. This has RGB rings on both sides of the fans, which is going to give us a lot of illumination so that we can have our system all be lit up without having to run any sort of LED strips. Now the last thing is we are going to be using the XT Hardline from Corsair. This is actually a frosted tube. This is something new for me. I've not actually used this tubing, and I think it looks great because it gives this appearance of being cold. Got this real nice frosted effect, which I think is going to make the system look like it's nice and cold. So obviously you need some sort of coolant. So we got our XL5 Clear from Corsair. Now this we can actually dye to be any color that we want. So I'll be using approved water cooling dyes, which are designed for PCs. You don't want to use food coloring or anything like that, nothing food based. And we can custom mix it to make it the shade of blue that we want. Just a slight touch of blue, which will look really nice in this frosted tube because it will really pick up the color and make it nice and translucent, and will really show it. So we've got a 1 liter bottle of that. We've actually got 2 liters of this to make sure we have plenty. And then last but not least, we need our fittings. We need stuff to actually attach all of these tubes together. So there's 2 types of fittings from Corsair. We've got the XF compression fitting. This is designed for soft tubing. So this has a barb that you put the tubing on, then you slide the collar down and lock it down. And that does two things. One, the barb is responsible for making the seal with the inside of the tube. The compression clamp its only job is to make sure that the tubing doesn't come off. So the collar is not responsible for sealing the tube. If you make sure that the sizes match, if you have, say, a 14 or a 10 by 13 compression and that same size tubing is listed, then you know they're going to be compatible and the collar will fit. But we're going to be using compressions, hardline compressions on this particular setup because we are going with the hardline tubing. So soft tubing barbs, hard tubing with compressions. So as long as you make sure that the types match and the sizes match, they're always going to be compatible with the tubing. And then because we're using hardline, and this will work also with soft tubing, we do have some 90-degree fittings and some 45-degree fittings. This just allows us to not have to rely completely on bending the tubes to get things nice and orderly. We can use 90s and 45s where they make sense so that we don't have to bend everything all the time. Bending looks cleaner, but it's also a little bit harder. So we've got a wide range of fittings from Corsair that will allow us to be able to make things nice and tidy without having to worry about wasting tubing when it comes to bending it. Now, speaking of bending it, we're going to be using the XT Hardline bending kit from Corsair, which comes with the saw, it comes with the clamp, the deburr tool, and then it also has a little jig on there so that you can get perfect 90s so that as you're bending it, you don't have to sit there and do the method like I used to do, using the edge of the table and going, okay, if they're parallel in both corners, then we know it's 90. It's actually got a radius bend tool in there so that you can get perfect 90s every time. So I like to start with water cooling the graphics card first because we can do it outside of the case. It's a lot easier to work on. The XG7 RGB water block is going to include a back plate for it, as well as all the instructions that we need to be able to get it nice and installed. I mean, yeah, we want it installed nicely. That's the way we do things around here. So here's our water block right here from Corsair. This water block, like I said, is designed to work specifically with the Asus Strix RTX 3090. So you're going to want to check the website to make sure they have a water block that's for your specific graphics card. It will have a fitment guide in there that will tell you everything you need to know about which cards they will fit. You can also search for your particular model to see if they make one. But the nice thing is they've got all of the thermal pads pre-installed on the back. Same thing with thermal paste with this little plastic cover right here to make sure that you don't mess it up. We got our RGB cables right here on the back, which are also pass-through. So we can connect multiple Corsair RGB devices without having to use a bunch of headers. And then we also have an extension cable right here that allows us to connect it to our standard motherboard. So if you're not using a Corsair product for controlling your lighting, you can connect it to your motherboard's ARGB header or an ARGB splitter so that you have control over all of your devices. And then if we look at the back right here, we've got our manual, we've got our keys and our plugs to be able to remove our fittings, and then we've got our Corsair backplate. So follow the instructions that are in your particular manual for your graphics card, which will have complete teardown instructions and installation instructions so that your graphics card is installed properly. Because if you don't make a good connection between the die and that cool plate or cold plate right there, you're not going to get the cooling that you want. In fact, you may even slow things down by creating thermal throttling. All right, so now that the XG7 3090 block is installed, we are going to just kind of snug down our screws in sort of a star pattern, starting from the screws right around the GPU core, which are these four, and work our way outward. So when you're installing it, just get everything kind of snug, make sure everything lines up before you start tightening anything down, and then work your way to the outsides of the block, tightening the screws, but not going too tight. You don't want to strip them. It's kind of easy to strip screws if you're not careful. These are very fine threads and such. But as you can see, it's a perfect fit. One of the easiest blocks to install because of the pre-applied thermal pads, pre-applied thermal paste, and it looks good too. So now we're going to put this inside of our system, and the next thing we're going to do is screw it down because we obviously don't want it to fall out. But we're going to go ahead and move on to our CPU block because it's quite a bit easier than the GPU, but obviously the GPU is just an optional step if you're going that route. But I prefer to do it first, that way I know it's all ready to go so that we don't do the tedious stuff at the end. We save that, the easy stuff for the end, so we end on a high note. And before we install the CPU block, I like to take out all of the RAM, that way it's not in our way. But the XC7 is actually really easy to install. It comes pre-installed with the Intel bracket already on there, but since we're using AMD, we're gonna be switching over to this AMD retention bracket. You can see all the screws are already retained on there, and they're self-retaining, so you don't have to install anything there. And this is gonna use the same factory backplate that's found behind the socket in all AMD motherboards, and this will thread right into that. But we've got to change over our block right here. Be careful on the back. We've got pre-installed thermal paste that we don't want to mess up, so be careful with that. You do have a little cover here that you could leave on there so that you don't accidentally mess it up. But since we're taking off this bracket, we want to be super gentle. So we're going to turn this clockwise until it comes loose. Pull out the block, move the bracket aside. We'll take the AMD bracket, take the block at that same 45-degree angle, and then turn it counterclockwise into place. This is actually going to be very, very simple. You're going to line it up and screw it down. So you're going to want to turn the thumb screws a little at a time, clockwise, going in a star pattern until the threads completely bottom out. Now the threads on here are cut to a certain length, but you want to go until they stop, and that will give you even tension across the IHS on the CPU to give you maximum cooling. So once you're done with that, you'll take your RGB cable, sort of run it to the side so we can do our cable management portion at the end, because we all know we want that RGB goodness. All right, so we're getting ready to set up the radiators now, which means we have to figure out the direction of airflow, where the fitting's gonna go, and which screws to use. So I've already taken all my fans out, and one thing to keep in mind with airflow for fans is it always goes from the non-cage side to the cage side. So that's the direction of the airflow. Since we're gonna be running one fan on each side of these radiators, we also need to determine what's gonna be push and pull, whether we're not going push-push or pull-pull on the rads. But I wanna talk about the screws here real quick. This is where a lot of people can cause damage if they're not careful. So you got 3 different size screws that come with the Corsair radiators. You're gonna have a really long screw, you're gonna have a slightly shorter screw, which, stand up. Okay, you got a slightly shorter screw, and then you got a short screw. So these are designed with very specific use cases in mind. So this is the front panel mount for the 5000D airflow that we have, and we're gonna be mounting our radiator to this. Now we're gonna put the radiator on the back side of the fans, with the fans in between this shroud and the rad. The reason for that is we want to be able to see the fans on the front side of the case. In terms of the way that the airflow works with pull or push, it's really not going to make much of a difference on which side you put the radiator on. So don't get caught up on, oh, it should be pull or it should be push. It really doesn't have any sort of a major difference that's even truly measurable on which side they go on. But the long screw is going to be for when you're mounting through a case, through the fans into the radiator. So for example, if you're gonna be taking this radiator and mounting a fan on this side of it, and then having it go through a case like a little case shroud like this, you've gotta have a longer screw to account for the thickness of this metal, otherwise the short screw won't make it all the way to the piece. So if you push it through like this, you can see on our fan right there, we've got that extra distance sticking up, and then that's plenty of length to be able to mount it to our radiator. So on the front of this setup, I'm gonna be doing sort of a sandwich where we're gonna be going screw through the metal bracket, through the fan, into the rad. Now obviously I have the fittings facing the wrong way. They're facing this bracket, which would not do us any good if we were trying to actually have a functional setup here. So what I'm gonna do is flip this around, and I personally like to have fittings on the top, because fittings on the top will make it easier for air to move through the loop. So what I'm gonna do now is I'm gonna go ahead and get these front fans and rad set up so that you can see what it looks like inside the case. All right, so we have 3 different setups here for different rads and front fans based on where they're going in the case. So you can see this radiator, we have all 3 fans set up as pull. It's gonna be pulling air through the radiator. And this guy is gonna actually be going on this back wall right back here. Now, something else that we have to consider too moving forward in the next scene is I have to attach the pump res combo to one of these in some way. It's more than likely gonna be on this one. But this is the top radiator. Now, because this is pulling air into the chassis, we need to exhaust that air. So you can see once you put this at the top of the case, we got our fittings facing down so we can access them, and the fans are pushing air through. So this is gonna be going up in the top of our case, just like this. So you'll want to push all your wires through your cable management holes. Same thing for the front fans here. Now the fans on the front are also going to be pulling air in. So you can see we've got the cage side facing us. Now this is one of the reasons why I'm a huge fan of these particular fans, because we've got the rings on both sides of the fans. So the front of the case is going to be lit by the hub ring, which lights up the fan blades, and then the ring around the actual cage. And on the back side, we're still gonna see the lit up ring on the back side of the hub, as well as this ring on the cage. So you got lighting on both sides of the fan, giving you the most light without having to run any sort of RGB strip. So let me go ahead and get these installed, and we're gonna do that using these short screws, which I showed you earlier, because the short screw is designed to mount the radiator directly to a piece of sheet metal, whether it be the back side of the case or the top of the case or a bracket like this. All right, so we got our radiators mocked up and we got our front fans in. Now you'll probably take these in and out a couple of times as you're trying to get everything sort of lined up to figure out where the fittings are gonna go, where you want everything kind of routed. But as you can see, we've got these 6 fans working as an intake. So this is kind of a channel of air coming from the corner here, but that's gonna be a lot of intake. We put our fittings at the bottom on this back rad because it gives us more clearance to be able to access it. And then we move the fittings, which I would typically put in the rear, to the front, because again, this is a much open area, easier to get to our fittings, or our barbs right here, and our ports to be able to put our fittings on there. So it's time to get the pump in there, now that we have the radiators and the fans and everything where they're gonna go. The nice thing about the XD5 is the fact that it comes with the mounting brackets to be able to mount it to any fan and or radiator. So here's our pump, here's the bracketry with the hardware. We've got our manual. So this will show you which fittings and which ports do what, because you want to get your inlet and your outlet set properly. And then here are the different brackets that we have available to us for 120 millimeter fans and 140 millimeter fans. So one of the things that comes with the pump is actually this coolant temperature sensor, which is really nice because if you're gonna hook this up to your motherboard, which a lot of motherboards, specifically this Asus board that we have as well, has temperature sensing probes on there, or headers that you can attach a probe like this to, you can control your pump through the actual coolant temperature. So you can put this on the back side right here where it's not visible, plug it in right here, and then what we'll do is it'll give you a temperature readout to be able to start to ramp up or slow down the pump based on temps. And it's got plenty of wire links to it, so you can set it anywhere inside the system. Or you can connect it to the Commander Pro, because the Commander Pro also has a temperature sensor on there. And this is really nice to see. Not a lot of, in fact, I don't know of any other reservoirs that actually come with a temperature sensor on there. So that's kind of nice. You've got plenty of fittings on here for in, out, and then you can have a drain plug or a valve, which we'll be attaching in this particular loop, set up to the system so that you can get the coolant out of there nice and easily if you want to. On the return line for the top of the reservoir, you can see we have this push down tube. And what this does is this means you can have coolant enter the top of the reservoir, but then it will enter the fluid down here at the bottom rather than having a waterfall effect, which can make a kind of an ugly sound. Well, unless you want it to sound like a fountain. But worse than that is it will cause aeration of the bubbles and the percolation in there. So by having it push down into the fluid level means that you can still have some air available at the top of the reservoir where all the bubbles can escape to. So the pump has got a lot of features built into it that are really nice, that make things just easier and more user-friendly when it comes to getting air out and having it all set up. So just to recap, we've got the radiators in, I've got the ports on the side I want them to be on, so we got the ports on this side of the rad because there's more room here. We already showed you how we had to kind of rethink the way we were gonna do that loop. I've got the fittings on the bottom on this back rad simply because once the top one's in there, you don't have enough room to be able to have fittings there. So, but fortunately, because we have this radiator horizontal and we have extra air that's gonna be in the reservoir allowing air to escape, eventually any air that's caught in the top of this radiator will make its way to the reservoir. You can see I started adding some fittings onto here. And the fortunate thing about Corsair having so many different types of fittings is the fact that we can have our drain plug on here. So we're just using this 90-degree fitting right here, which is also a Y splitter, so that we can have the plug come straight out for the drain. And then we have it coming off here at a 90, because I'm trying to get, this is the outlet of the pump. So now we have to start thinking about our loop. We have to think about the order which things are going to flow. And these are some of the things that you want to think about as you're putting in the parts. But we have to determine our flow order now because we had to put things in a certain way to fit in the case neatly and still have access to our fittings. So this is the outlet from the pump, and we're gonna be going into this radiator first. Now I decided, because the bottom rad has to have an outlet that's gonna go over to our GPU, I want to inlet from the pump to this radiator on the front side. That way we can keep the tubes on the same side they're coming in and out of. So I use this Y adapter plus an extension plus a swivel 90. That way I could move it over to that side of the pump without having to do it through bends. Now you can do it through bending tubing. And unless you have a lot of experience bending tubes, which you probably don't because this video is designed towards the beginner, you would just want to get a lot of extra tubing to make sure that you can get the bends nice and tight. I prefer to use fittings for one, I like the industrial look it kind of gives. It gives more of a plumbing / industrial look. And two, the bends are perfect because they're 90s. So our flow order at this point is going to go from the pump over here through these fittings into this right side fitting on the radiator. It's going to come out of that radiator up or across, up and over into the GPU. Now normally you would go, now also too, real quick to recap, flow order in terms of which component gets cooled first does not matter. That needs to be bold and underlined. There's this misconception out there that if you cool a GPU first, you're just gonna be warming up your CPU. That's not the way it works. Not enough coolant temperature change happens once it goes over the cold plate in the GPU to cause any significant raise in temperature in the CPU. You might see 2, maybe 3 C difference at the most. Remember, this is not a car. You are not dealing with massive temperature differences between the coolant temp and the thing you're cooling. You are not dealing with 200 degree coolant or 200 Fahrenheit coolant to try and keep it cool with something that's way colder, like the coolant is running, you know, much, much colder than that. So you don't have these great deltas in temperatures. So to keep things nice and neat, instead of trying to go from the pump and that rad to the CPU, back to the GPU, back to up here and having crisscross tubes everywhere, we can go in the flow order that makes sense in terms of the tubing. So we will be going from pump to radiator, from radiator to GPU, GPU to CPU, CPU to radiator over here, and out of radiator into the top of the pump. Now is when we get to start having a lot of fun. This is where we get to start bending our tubes and planning our order. And what I like to do once you have the loop order figured out is to do the easy bends first. The easiest one here so far is going to be from this bottom radiator to the pump, this outlet from the pump to the inlet of the rad. All right, so let's talk about bending rigid tube. You're gonna need a heat gun for this. There's no way around that. The only way you can bend it is by using heat on there. Now, the only other way you could use rigid tubing without having to, deal with bending it is if you use 90s everywhere and offsets and stuff, which can get very expensive very quickly by adding all of those additional fittings. So the nice smooth 90s that I can do with the tubing, I'll do, and then I'll do fittings like you saw over here with the pump. But we're gonna use the XT Hardline bending tool kit, which accommodates both 12mm and 14mm tubing. This is a 14mm tube here. And you can see everything that comes with it. Here's our bending core right here. So this is designed to go inside the tubing, which gives us a nice mandrel bend, because when you heat it up, if you don't have something inside to make it retain its shape, it's going to crush. So we also have this tool bender right here, which will allow us to be able to bend perfect 90s for either our 12mm or the 14mm. You have these stops, which will allow you to measure the depth. So if you take this little stopper out and change the location of it, that will allow us to determine how far down the tubing goes before it stops. So then we could heat the tubing up, get it nice and soft to where it's pliable. Then this will allow us to bend our radius. We can go to complete 180 if you wanted to do some crazy bends that way. Or you can see right here, we've got these lines that are marked for 45, 90, and then what, 190 plus 45? Yeah, 130, math, this is good, we got that. Other thing we have in here is, very important, the saw, so that we can actually cut the tubing. This material is PMMA if you were curious, but to be able to have that saw allow us to cut things nicely, we have this little clamp right here that will allow us to clamp our tubing down, and then we'll be able to saw through the ends right there. And it's got this little lip so that you can actually hang it over the edge of the table, that we have a nice solid surface to be able to mount it to. You want to make sure that you give yourself plenty of length so that you have excess. You want to have your tubes be a little bit longer. That way you can trim off the excess. You can't make it longer, but you can make it shorter. Now after you cut the edge, you're gonna see it's kind of rough, and you wouldn't want to put that inside of your system because that would probably cut your O-rings. So we have this deburr tool, which will give us both an internal and an external deburr ability. So you take the pointy end, put that in the inside, just give it a few turns. The sound is normal. That will give us a nice smooth inside, so we're not gonna, we'll have no burr showing there. Then you switch to the external portion of the tool. And again, don't put a lot of force on it. Just push gently against it as you turn. And that gets rid of all the sharp edges. So now we would be able to put this inside of our system and not cut any of our O-rings, which could lead to a leak. So now it's time to go ahead and bend our first tube. So we know that this is just gonna be a plain 90, and it's gonna be going from this port on the radiator to this port on the pump. Now the 90 doesn't need to be right in the middle of this tube. We know it's a little bit closer to the side panel. A little pro tip, don't put Sharpie or dry erase markers or anything on here. Even if it's dry erase and it wipes off with your finger, as soon as you heat it, it will absorb into the plastic, which means it won't come off after you're done. So what you want to do is kind of get the best eyeball of where you think your 90 should be placed by just kind of holding your tubing up and going, okay, it needs to bend roughly right around there. So we're going to put this core in on the other side, and then we're going to start heating the tube. Once the tube starts getting soft and kind of wanting to bend, that's where we will go ahead and put it into our vise right here, or our little bending clamp, so that we can get our nice curved radius. You'll notice the clamp is also curved on the inside. That will also allow it to keep its round shape rather than getting that kind of a, even with a mandrel, sometimes you can get it sort of crushed slightly and get what looks like kind of a flat spot if you were to do it on the table. This nice curvature in there will make sure that it maintains its shape. So here's our very first bend. It's our 90-degree tube. We can pull the mandrel out once we get it out of there. So you can see, nice, perfect 90. It maintains its shape. It doesn't squish or flatten out. A little pro tip of taking the tubing or the core out, if it kind of gets stuck, just sort of twist it as you pull, and then it will work its way out like that. It kind of releases some of that surface tension. So there's our very first 90. Now you can see it's obviously way bigger than what we need in terms of length, right? So this is where now you'll kind of get everything sort of lined up, measured out, and then make sure you cut a little bit longer than what you need. You can always shorten the tube. You cannot make it longer. So this is about the time you start getting really excited because you can start to see it sort of take shape. So I just made that 90, and then I just trimmed down the links until they were perfect. Now, some of the things that I look for here is you want to make sure, especially going for like a 90-degree, like everything's got nice 90s and squared off. The things I'm looking for here are the things horizontal that should be. Is this fitting horizontal, or is it being, pushed up weird, or is it pulling down to meet the tubing? If it has to go down to meet the tubing, you made it too short. So I just make sure that I trim small amounts at a time until everything is perfect. That's why I don't have the collars on here. You can see that we have the collars and the O-rings. I leave these off until everything in the build is done and ready to be locked down, because I don't know if I'm gonna have to make some sort of an adjustment somewhere that might make some of these tubings be off. Instead of, then I have to take all the collars off and whatever. So I keep them aside in a safe place. That way, once we're ready to start filling this and getting some liquid in here, then I put all the collars back on. Don't forget that part. I've seen people do that before, where they forget to put the collars back on and then it's full of liquid and they're like, oh man. All right, so all the tubing bends are in. You can see I've got all the caps on. I didn't put the caps on until everything was lined up how I wanted it. All the tubes were done. That way you're not sitting there fighting with the collars to try and get them on and off. So you also might notice some time has elapsed here. I've got a haircut and change of clothes, because one of the things that I think is most important is you set aside plenty of time to do this right. Take your time, be patient. If this is your only rig and you're down, make sure you schedule that during a time in which you don't have to have like a paper due for school or work done at work, where you can take your time on this and not rush. Another really important tip too is before you start bending your tubes, do a test piece. Take a small test piece, bend it, see how long it takes before it blisters, see how long it takes before it's malleable enough to where you can get a nice even radius bend without crushing the inside diameter or stretching the outside diameter. Trust me, you can save yourself a lot of headache if you get an idea of how much time and heat is needed for each type of material. So the next thing to do now is we need to prepare to fill our loop. So I am going to be using the XL5, like I said. It's a clear coolant. 1 liter or 1,000 milliliters should be enough for this size loop. We don't have a giant reservoir. Also, I'm going to be using a dye. Use a dye from a reputable brand designed for water cooling. Do not use food coloring. Food coloring is not appropriate for a loop. You do not want food grade product. It will grow bacteria and growth. You don't want that in your loop. But what we've got to do here is get our loop also prepared to be able to fill. So if you've got a drain plug and you don't have a plug on the end of it like this, make sure you plug it. Even though there is a ball valve in there, the last thing you want to do is to find out that there's just a little bit of seepage past that ball check valve. So use one of the plugs that are applied or supplied, or get some favorite decorative plugs that you want to cap that off. Also, make sure that the valve is perpendicular to the flow. That's how you know that it's closed off. We are also going to disconnect our 24-pin power supply cable from our system. Now, depending on whether or not your system's already complete or you're building it for the first time, we'll determine whether or not you're gonna do this out of the case or unplug it or whatever. But the reservoir also comes with this jumper. And what this jumper will do is it will jumper together the 12-volt inside of the harness, which is going to trigger the power supply to turn on when you turn on the plug on the back of the power supply, which will allow you to be able to run your pump without turning on the system. You don't want to turn on the pump and fill the system with the system on for a couple of reasons. One, there's gonna be a ton of air. You're gonna be turning it on and off. You gotta get all the air bled out. Two, that's also part of our leak test time. That's probably where a lot of people fail, is they think like, okay, we're ready to go. And then off they go and they burn up something because they've got a drip that they didn't see coming. But as long as the motherboard and the CPU and the GPU aren't powered on, anything that drips on there won't be a problem as long as you let it dry completely prior to powering it up. So because I mentioned on this one, we want to go with a little bit of a kind of a frosted, remember ice has a slight blue tinge to it. And that's just because of the way that the water refracts light as it goes through it. It actually pulls out the blue spectrum. And I kind of want that here because I want it to look like it's frozen because of these translucent tubes. So I've just got this little tote right here. We're good, I think. Anyway, I'm wiping this out. You can do this in a clear bottle. We don't have any clear bottles hanging out here. So we're just using this bottom half of a coolant jug where I'm gonna pour the coolant in here and then I'm going to mix up the dye and then I'll use a funnel to pour it back into the bottle and I'll show you how we'll get it inside the system. Now that we have our coolant mixed up, let's talk about an easier way to fill it. So because the reservoir here gives us multiple ports on top, we have one not being used because obviously the return on top, we're on the right side here with the push down tube. I've also left the plastic on here. I don't take the plastic off the reservoir until everything is done. But we're gonna be filling it from the top right here. Now, one thing you need to understand is that because we're not gonna have another port open to allow air out, air is gonna have to escape through the same tube that you're filling with. So don't over pour, don't pour too fast. The air will cause bubbles to percolate out and it will get kind of messy. But I like to take just a piece of vinyl tubing, you can get this from any hardware store, and then just a cheap barb fitting or something from buy one extra barb fitting and then you'll be able to fill it this way. And then I got this tiny little long snout funnel that will push down inside the tube. This allows me to thread this into the top, have this hanging out, and this is where I fill it. But before we do that, we need to get ready to do our leak test. We're just gonna take white paper towels, and I recommend white, not blue shop towels, especially right now since I got blue coolant. You want to use white because if you're using a colored dye, it will be really obvious if it starts dripping anywhere. So you wanna put this underneath all of the connections. So we got this bottom one right here. It'll do two things. One, it'll catch any drips. Two, it will allow us to identify any drips because it's white and it will be really obvious and show up. So think of this less about catching things to protect, more so just to be able to make it super obvious and be able to see that it's dripping. Now, if you don't have a funnel and some spare vinyl tubing and a fitting, you can order from anywhere online pretty much just a squeezy fill bottle. This makes it a little bit easier to control. You get it down inside the reservoir and you just squeeze to fill it until the reservoir is full. And then you turn on the power supply to get the pump going. Make sure it's plugged in obviously to power. And then as soon as the reservoir runs empty, turn it off, refill the reservoir and keep that going until you have coolant coming out of that tube. Once you do, fill it up all the way and then let it run for at least a half an hour to allow the air to start to circulate and make its way to the reservoir. The level will continue to drop as long as air is making its way there. Continue to fill it up, but leave a little space for air to actually be able to accumulate at the top. You don't want to fill it all the way to the neck. And just keep that going until you have, well, what seems to be all the major air bubbles moved, and then we'll talk about how to get rid of the micro bubbles. Okay, so now that our loop is full, there's gonna be a lot of air in this system. So what we're gonna do next, we're gonna let it run, obviously for our leak test, but we wanna promote the movement of air. So you're just gonna sort of lean the system, and see as I do that, we start to see bubbles move. You can hear them moving. You can see them making their way back to the reservoir. Lean it that way, lean it the other way. See all the air moving through the tubes. The nice thing about clear tubes is that you can actually see it move. Tip it backwards. Also, make sure the cap is on the reservoir while you're doing this because you don't want to leak it all out everywhere. And then if you give it just a little tap when you go down with it, don't smash it on the ground, but if you just tap it down, you'll loosen some bubbles up too. You'll break that surface tension. I would recommend doing a leak test at least for 2 or 3 hours. Some people will say 24 hours. I find that if it doesn't leak in the first few hours, it's not going to leak at all. So we're gonna let that go. You'll notice the coolant will start to clear up in the reservoir. Right now we still have the plastic on it, remember that. So that's one of the reasons why it doesn't look super clear and shiny. But you're gonna let this go for a while. Eventually all the small micro bubbles, which are aerating the fluid right now, which are making it look cloudy, will clear up. That'll just take some time. And you don't wanna fire, as tempted as you are right now to fire up your system, I mean, we don't even have GPU cables installed yet, so it's not gonna fire up. Let the leak test do its thing. Don't get impatient, give it time. Make sure everything's dry. go get something to eat, come back, look, if the paper towels are still dry, give it an hour or two. If they're still dry after that, now we can talk about hooking up the rest of our systems. All right, so here's the finished product after a couple of afternoons worth of work. Like I said, it's really important to just set aside some free time so that you're not rushing yourself to try and get it done. Take your time. You start feeling frustrated, walk away from it for a little bit, come back to it later when you start to feel a little bit rejuvenated. But you can see the final product really came together. A lot of the micro bubbles are gone. The cloudiness is kind of going away. It's not as aerated. It's nice and clear looking now. These surface tension bubbles here will go away over time. But you can see I also went ahead and got all of the RGB set up here with our QL fans from Corsair. So we have IQ installed, and it's now giving me, it's really slow and subtle, but it is sort of color shifting between a very icy blue to a slightly hued blue added to white. It's very subtle, but it is shifting back and forth to kind of give you a little bit of this glacier effect. I want this to look like the inside of a glacier. That's the cool thing about IQ is you can go in here and start customize stuff to pull some lighting theme together to go with your themed build. But anyway, guys, you can see it's really not that hard. We didn't use a lot of specialty tools to get this done. We just used the Corsair bending kit with their cord and the saw, the little, I guess it's technically a jig or more of a vise, their PMMA tubing, the deburr tool, and then the little 90-degree bending kit really came in handy. I don't usually use these types of tools, but the 90s were absolutely perfect, as you can see. It allowed me to get real sharp bends and keep the radius the same between all of them so they don't look any different. The only tool you might actually have to go out and buy would be a heat gun if you're gonna do rigid tubing like this so that you can heat up the tubing and bend it. If you're gonna use soft tubing, it's even simpler. You just need really sharp scissors or some sort of a tubing cutter that will cut right through the soft tubing without any problem. So set aside a couple afternoons and just be patient, and you can end up with an amazing build like this without too much headache. If you guys want to learn more about the HydroX line of water cooling products from Corsair, I have a link down in the description below. Once again, a huge thank you to Corsair for sponsoring today's video. If you guys have any best tips and tricks when it comes to doing your water-cooled loops, put them down in the comments below. There's a lot of people that will be watching this trying to do this for the very first time. And if you think I missed anything here that might be beneficial in terms of best practices or tips and tricks, comment down below. Thanks for watching, guys, and as always, we'll see you in the next one.